Nothing in the universe is still. Not one thing. Right now, you're sitting in a chair, thinking you're motionless. But you're not. You're spinning with the Earth at over 1,000 miles per hour. The Earth is orbiting the Sun at 67,000 miles per hour. The Sun is racing around the galaxy at 500,000 miles per hour. The galaxy is hurtling through space at over 1,000,000 miles per hour. And the universe itself is expanding, carrying everything with it faster than the speed of light. Nothing is still. Nothing has ever been still. Nothing will ever be still. And for most of human history, we had no idea why. Why is motion the default state of everything? Why doesn't the universe just stop? What keeps it all moving? Einstein discovered the answer. And it's not what you think. It's not momentum. It's not inertia. It's something far deeper, far stranger. Einstein realized that motion isn't something that happens to objects. Motion is the natural state of existence. Stillness is the illusion. And the reason everything moves is because of the structure of space-time itself. Space and time are not separate. They're woven together. And that weaving forces everything to move. Always. Forever. There is no such thing as absolute rest. And once you understand why, once you see what Einstein saw, it changes everything you thought you knew about reality. Let's start with the obvious question. Why do things move at all? You throw a ball. It moves. Why? Newton said inertia. An object in motion stays in motion unless acted upon by a force. Fine, but that doesn't explain why it started moving. You threw it. You applied a force. But why did your arm move? Because your muscles contracted. Why did your muscles contract? Because neurons fired. Why did neurons fire? Because of chemical reactions. Why did those reactions happen? Because of molecular motion. And we can keep going down, at every level, motion. But where does it come from? What's the ultimate source? Ancient philosophers thought there had to be a prime mover, something that started everything moving. Aristotle said it was God, an unmoved mover that set the universe in motion. But that just pushes the question back. Why did God move things? And if God can move things without being moved, why can't other things? The whole concept breaks down when you think about it. Einstein approached this differently. He asked, what if motion is the default? What if stillness is what needs explaining? Think about it. In everyday life, things slow down and stop because of friction. Air resistance, drag. But remove those forces, and what happens? Things keep moving forever. A planet in space doesn't slow down. It keeps orbiting. A photon of light doesn't slow down. It keeps traveling. The universe is full of motion because motion is natural. Stillness is artificial. It only happens when forces cancel out, when friction stops something. But in the absence of friction, in the vacuum of space, motion is eternal. So the question isn't why things move. The question is, why does anything ever stop? And the answer is, nothing really does. When something appears to stop, it's just that its motion has been transferred somewhere else, into heat, into sound, into the motion of air molecules. The total amount of motion in the universe never decreases. It just changes form. But Einstein went deeper. He realized that motion isn't just about objects moving through space. It's about objects moving through space-time. And this is the key. Space-time is a four-dimensional structure. 3 dimensions of space. 1 dimension of time. And everything in the universe is always moving through space-time at the speed of light. Always. You, me, this, chair, everything. We're all moving through space-time at exactly the speed of light. Right now. How is that possible? Because motion through space-time is divided between motion through space and motion through time. If you're sitting still in space, all your motion is through time. You're moving into the future at maximum speed. 1 second per second. But if you start moving through space, some of that motion gets diverted. You're now moving through space and time, which means you're moving through time more slowly. This is time dilation. The faster you move through space, the slower you move through time, and there's a limit. If you move through space at the speed of light, you have zero motion left for time. Time stops for you completely. If this sounds insane, you need to understand it before we go any further. Subscribe to this channel right now. What I'm about to reveal is going to completely change how you see motion, time, and existence itself. Hit that like button. Share this video with everyone. Because this is the kind of knowledge that doesn't just inform you, it transforms you. Let's keep going. Now, think about what this means. You cannot be still in space-time. You are always moving at the speed of light through the four-dimensional structure of reality. When you sit in a chair and think you're not moving, you're actually moving through time at maximum speed. You're traveling into the future at 1 second per second, and that's motion. Real, physical motion through the time dimension. This is why everything is in motion. Because spacetime has this built-in structure that forces everything to move through it at a constant rate. You can't stop. You can't slow down. You're always moving at the speed of light through spacetime. The only thing you can control is how that motion is divided between space and time. Sit still, and it's all through time. Move through space, and it's split between space and time. But the total speed through spacetime never changes. It's always the speed of light. Einstein discovered this by thinking about light. Light always travels at the same speed. No matter who measures it, no matter how fast you're moving. This seemed impossible. But Einstein realized it makes perfect sense if space and time are not separate, if they're part of a unified spacetime. And if everyone is always moving through spacetime at the same total speed. Light is special because photons have no mass. So all their motion through spacetime is through space. None through time. They move through space at the speed of light and through time at zero. That's why time doesn't pass for a photon. From a photon's perspective, it's emitted and absorbed in the same instant. It experiences no time. It only experiences space. And this is the maximum speed anything can move through space. Because it's the speed at which all your spacetime motion is devoted to spatial motion. Now, let's connect this to the motion we actually see, the Earth spinning, orbiting the Sun, the solar system moving through the galaxy moving through the universe. Where does all this motion come from? It comes from the Big Bang. About 13.8 billion years ago, the universe began in an incredibly hot, dense state, and it exploded. Not into space. Space itself expanded. Everything was moving away from everything else, and that motion has never stopped. The universe is still expanding. Everything is still moving apart. But here's what's interesting. The motion we see today, the spinning of planets, the orbiting of stars, that didn't come from the Big Bang directly. It came from irregularities. Tiny fluctuations in the density of matter. Some regions were slightly denser than others. Gravity pulled matter together in these regions. And as matter collapsed inward, it started spinning. Because of conservation of angular momentum. Here's how that works. Imagine a cloud of gas in space. It's not perfectly uniform. Some parts are moving slightly faster in one direction. Some parts are moving slightly slower. As gravity pulls the cloud together, these small differences in motion get amplified. The cloud starts to spin, and as it contracts, it spins faster. Just like an ice skater pulling their arms and spins faster. This is how stars form, how planets form, how galaxies form. All the rotational motion we see, all the orbits, all the spinning. It comes from these tiny initial irregularities, amplified by gravity and angular momentum conservation. And those initial irregularities, they came from quantum fluctuations in the early universe. Random fluctuations at the quantum scale that got stretched out by cosmic inflation. So, in a very real sense, all the motion we see, all the spinning planets and orbiting stars, traces back to quantum randomness amplified to cosmic scales. But Einstein's insight goes even deeper. He realized that gravity itself is not a force. It's the curvature of space-time. Massive objects bend space-time around them. And when space-time is bent, objects moving through it follow curved paths. This is what we call an orbit. The Earth isn't being pulled by the Sun. The Earth is following a straight line through curved spacetime. From the Earth's perspective, it's moving in a straight line. But spacetime is curved by the Sun's mass, so that straight line is actually a circle around the Sun. This is orbital motion. It's not caused by a force. It's caused by the geometry of spacetime, and this explains why orbits are stable. Why planets don't fall into the Sun. They're not resisting a pull. They're just following the natural path through curved spacetime. And that path happens to be an ellipse. Now, think about what this means for motion in general. Every motion you see is really an object following its natural path through spacetime. The path is determined by the curvature of spacetime, which is determined by the distribution of mass and energy. So when you throw a ball, and it arcs through the air and falls to the ground, it's following a curved path through spacetime. The Earth's mass curves spacetime, and the ball's path is the straightest possible line through that curved spacetime. We call it a geodesic. From the ball's perspective, it's moving in a straight line. But from our perspective, watching from within Earth's gravitational field, it looks like a curve. This is profound. It means all motion is really straight-line motion through curved spacetime. There are no forces pushing or pulling in the traditional sense. There's just geometry, the shape of spacetime, and objects following the contours of that shape. We've reached the halfway point, and I need you to really absorb what this means. Everything you think about motion, about forces, about why things move the way they do, it's all geometry. It's all spacetime, and Einstein figured this out. Subscribe to this channel immediately if you want to keep learning these truths. Hit that like button, share this video, because most people will never understand what you're understanding right now. And that gives you something rare, clarity. Let's continue. Let's talk about the expounding universe. This is motion on the largest scale, and it's the strangest motion of all. Galaxies are moving away from each other. The farther away a galaxy is, the faster it's receding. And some galaxies are moving away faster than the speed of light. Wait, didn't we just say nothing can move faster than light? That's true for motion through space. But the expansion of the universe is not motion through space. It's the expansion of space itself. Space is stretching, carrying galaxies with it. And there's no speed limit on how fast space can expand. So distant galaxies can recede faster than light, not because they're moving through space faster than light, but because the space between us and them is expanding faster than light. This is a crucial distinction. And it shows just how weird motion really is at cosmic scales. Einstein's equations predict this. General relativity allows for an expanding universe. In fact, when Einstein first applied his equations to the entire universe, he found that the universe had to be either expanding or contracting. It couldn't be static. This bothered him, because at the time, everyone thought the universe was static, eternal and unchanging. So Einstein added a term to his equations, the cosmological constant, a kind of anti-gravity that would keep the universe from collapsing or expanding. He later called this his biggest blunder, because Edwin Hubble soon discovered that the universe is expanding, Einstein's original equations were right. The universe is that always moving, always changing, and we now know that the expansion is accelerating, driven by something we call dark energy, which might actually be Einstein's cosmological constant after all. The universe is not just in motion. It's speeding up, expanding faster and faster, and we don't fully understand why. Now let's bring this back to you, to your body. You're made of atoms, and atoms are mostly empty space. The nucleus is tiny. The electrons are far away. But it's not empty in the sense of nothing there. It's full of quantum fields. And those fields are in constant motion. Virtual particles pop in and out of existence. Electrons buzz around the nucleus, not in fixed orbits, but in probability clouds. The atom is a storm of activity. Nothing is still, even at the smallest scales. And this motion is not random. It's governed by quantum mechanics, by the Heisenberg uncertainty principle, which says you cannot know both the position and momentum of a particle exactly. If you try to pin down an electron's position, its momentum becomes uncertain. It has to move. Motion is built into the fabric of quantum reality. There is no state where a particle is perfectly still. It's always jittering, always fluctuating. This is called zero-point energy. And it means that even at absolute zero temperature, even with no heat, particles are still moving. Motion is fundamental. Einstein didn't work on quantum mechanics much. He was uncomfortable with it, but he recognized its importance. And the motion we see at quantum scales connects to the motion we see at cosmic scales. It's all part of the same picture. The universe is a dynamic, ever-changing system. At every scale, from the smallest quantum fluctuation to the largest cosmic expansion, motion is the default. Stillness is an approximation, a useful fiction for everyday life, but not the fundamental truth. The fundamental truth is that everything's always in motion, has been, always will be. And this motion is not chaotic. It's structured. It follows laws, Einstein's laws, the geometry of space-time, the symmetries of physics, the conservation principles. All of this structure emerges from the fact that motion is fundamental. Here's another way to think about it. Energy. Energy is the ability to do work, to cause change, to create motion. And the total energy in the universe is conserved. It never increases or decreases. It just changes form. Kinetic energy, potential energy, thermal energy, mass energy, all interconvertible. And all of it is ultimately about motion. Kinetic energy is obviously motion. Potential energy is stored motion. Thermal energy is random molecular motion. And mass energy. Einstein showed that mass is energy. E equals mc squared. Mass is frozen energy, concentrated motion. When you convert mass to energy, like in a nuclear reaction, you're releasing that frozen motion, turning it back into kinetic energy. Motion of particles, radiation, heat. Everything is motion. Everything has always been motion. And Einstein showed us that mass and energy are the same thing, just different forms of motion through space-time. Now, let's talk about what this means philosophically. If motion is fundamental, if stillness is an illusion, then change is fundamental too. The universe is not a collection of static objects. It's a process, a flow, a constant becoming. Nothing is permanent. Everything is in flux. Heraclitus said this 2,500 years ago. You cannot step in the same river twice. Because the river is constantly flowing. It's never the same water. And you're constantly changing too. Every cell in your body is in motion. Every atom is vibrating. Every molecule is reacting. You are not a thing. You are a process. a pattern of motion that persists for a while and then dissipates. And this is true for everything. Stars are processes. Galaxies are processes. The universe itself is a process. And recognizing this changes how you relate to reality. You stop trying to hold on to things, because there's nothing to hold on to. Everything is already slipping away, already changing, already moving. Einstein understood this. He saw that the universe is not made of things. It's made of events, happenings, processes unfolding in space-time. And we are part of that unfolding. We are not separate observers watching the universe from outside. We are inside perceiving along with space. And our consciousness, our experience of being, is itself a process, a pattern of neural activity. Motion in the brain, electrical signals propagating, chemicals binding. It's all motion, always has been. And when that motion stops, when the brain stops functioning, consciousness ends. Not because some immaterial soul leaves the body, but because the process stops. The motion ceases, and without motion, there is no experience, no time. Existence. Motion is not just what things do. Motion is what things are. Let me give you one more example. Light. A form of light is pure motion. It has no mass, no rest state. It exists only as motion through space at the speed of light. From the moment it's created to the moment it's absorbed, it's moving. And from photon's perspective, nucimi passis, it experiences a single instant. Creation and destruction simultaneously. This is what pure motion looks like. No time. No change from its own perspective. Just pure spatial propagation. And this is the limit. The maximum expression of motion. Everything else, everything with mass, moves slower through space because it's also moving through time. But light moves only through space. And that makes it the fastest possible motion, the cosmic speed limit. Not because of some arbitrary rule, but because of the structure of space-time itself. So why is everything in the universe in motion? Because space-time forces everything to move through it at the speed of light. Because motion is the natural state of existence. Because stillness is an illusion created by forces balancing out. Because the universe began in a state of expansion and that expansion continues. Because quantum mechanics forbids perfect stillness at the smallest scales. Because gravity curves space-time and objects follow those curves. Because energy is conserved and energy is motion. Because we live in a dynamic, ever-changing universe where process is fundamental and objects are temporary patterns in the flow. Einstein discovered all of this, not all at once, but piece by piece, through thought experiments and mathematics and profound insights into the nature of reality. He showed us that the universe is stranger and more beautiful than we imagined. That motion is not something that happens to things. Motion is what things are, and that changes everything. If this video changed how you see motion and existence, then you know what to do. Subscribe to this channel right now. Hit that like button. Share this video with everyone who thinks they understand how reality works, because they don't. None of us fully do. But we're learning. We're uncovering the deep truths that Einstein glimpsed and that modern physics continues to reveal. And I'm going to keep bringing you these insights. These profound ideas that make you see the world differently. So subscribe, share, and I'll see you in the next video, where we'll explore even deeper mysteries of the universe.